I welcome you all for this presentation. In this presentation, we are going to discuss about array implementation of queue. This is the overview of this presentation. Operations in queue, then algorithm, then declaration, then two main operations in queue like EnQueue, DeQueue, then the common operation, that is display operation, followed by summary of this presentation. We all are aware that we can perform two main operations in queue. One is the EnQueue operation, that is insertion, and another is the DeQueue operation, that is deletion operation. So this display operation is to display the contents of the queue. And in order to perform insertion and deletion, we need, because we know that insertion is performed at one end and deletion is performed at other end. So what are the two ends we are using? Or for insertion, we are using the rear end, and for deletion, we are using the front end. So already we are aware of this. So always we have to remember this. Deletion is always performed in the front. How we have to remember is, we are just standing in a queue, and who is entering first? Those who are standing in the front are only entering first. So whoever is standing in the front is deleted first. So only deletion operation has happened at the front and insertion happens at the rear end. Third one is display. In order to print the elements in the queue, we are having this operation. Let us see the algorithm. Algorithm means it is not very complex. It is just the step-by-step procedure to solve any problem. So here, this is one format or guideline only. You can modify the given algorithm also based on your program or based on your understanding what you are going to write. Based on that, you have to change the algorithm. It is not necessarily in the lab I am giving one algorithm, but you are writing some other program. So whatever the program you are going to write, for that only you have to write the algorithm. That is very, very important. So here the first step is include all header files which are used in the program and define a constant size. That is, if it is array implementation, we need to define the size of the array. So only here we are having size with the specific value. So before this step, we can write start the program, and in the last step we can write end the program also. Because in the lab we used to write, so it is correct only, so no need to worry. If it is there means you can have it, otherwise if you are not interested to write means also it's okay. So second is, we are declaring all the user defined functions and whatever the variables we are going to use in the program, all those things we are declaring. Then we are creating a one-dimensional array because it is a array implementation of queue. So we are just creating a one-dimensional array and we are defining the size of the array as size. So we are having int queue of size. Size here already it is defined because whatever the macro we are going to define, there we are defining the size of the array. So here that size only we are writing, and next we are defining two variables because here insertion is performed at one end and deletion is happen at the other end. So we need these two ends, front as well as rear. Front is for deletion and the rear is for insertion. And initially we have to initialize these two ends to -1 because it is an empty queue. So we have to initialize to -1. That means that int front equal to -1 and int rear equal to -1. Then implement the main method by displaying whatever the operations list and make via suitable function calls, all those things we are using. Whatever you need, we can write it. Next is we are just writing the steps for the operations. So here we are having the EnQueue operation, that is inserting a value into the queue. So if you want to insert any value into the queue, what we need to check? Whether the queue is full or not, we have to check. If the queue is full, because it is array implementation, the maximum size is there. So if the queue is full, we can't insert anything. So we have to check the condition that queue is full or not. For that we are having that rear equal to size -1. And the next what we are doing, if it is full, then we are displaying that queue is full, that is overflow condition is there. So we can't perform any operation. And if it is not full, then we have to increment the rear value. For insertion, always we have to increment the rear value because insertion happens at the rear end. So we have to increment the rear value by 1, that is rear plus plus, and assign the value to queue of rear. Wherever the index is there for the rear, after incrementing, index is in 0 position. So we are incrementing we are inserting the value in the queue. Next is DQ, that is deleting a value from a queue. Here what we have to check is we have to check the underflow condition. That is check whether the queue is empty or not. So in order to check the queue is empty or not, we are having a condition called friend equal to rear. So if it is empty, then we have to display that queue is empty. So deletion is not possible. There is an empty queue, then what to delete? So deletion is not possible. And we have to terminate the function. If it is not empty, then we have to increment the friend value by 1. That is friend plus plus. Always deletion happens at the friend. So always we have to increment the friend value only. So friend plus plus. Then we are displaying that queue of friend as a deleted element. Then we are checking that both rear and friend are equal. So if both friend and rear are equal, then what we are doing is, it is a empty queue. Meaning is empty queue. So we are just setting both friend and rear to -1. Always empty queue means the rear and front position is -1 in array implementation. This is very important. Next is the display operation. Here we are displaying the elements of the queue. So in order to display the elements of the queue, we have to check whether there is any content available or not. So what condition we are checking? That underflow condition again we are checking. That is if queue is empty or not. That is a friend equal to rear we are checking. And if it is empty, then what we are doing is we are displaying that queue is empty and we are terminating the function. And if it is not empty, then we are defining an integer variable I and we are setting I equal to friend plus 1. Then one by one we are just displaying. So queue of I value and increment I value by 1. And we are repeating the same procedure until the value reaches the rear position. That is I less than or equal to rear. Up to that we are just printing all the elements in the queue. Next is the declaration part. Those who are familiar with the C programming all are familiar with this. So here we are having, we have to include the header file, that is include stdio.h. It is for the printf and scanf. Then console input output.h. It is for the clear screen and get CHO functions and all. If you want to use at that time we can use. This is a macro hash define size 10. Then we are just declaring the functions whatever we are using in our program. Then we are declaring the variables also. Then we are having the main function. Here we have used the switch case. So each and every time user is giving any choice, that particular choice is executed, and if you want to exit, then we have to press 4. This is otherwise if any other number you are pressing means it will be displaying that it is a wrong selection. Try again. It is a default case. Then coming to the EnQueue operation, already we have seen in the algorithm that we have to first check the overflow condition for insertion operation. So if rear equal to size -1, then we are printing that queue is full and insertion is not possible. Otherwise, what we are checking that if friend equal to -1, because it is an empty stack. So if friend empty stack means and if you are inserting one element after incrementing the rear position, the friend also has to point to the first element. So friend, we are checking that if friend equal to -1, if this condition is true, then you have to change the value of friend to 0. Then only you have to increment the rear position and place the value in the rear position, and you are just printing that insertion success. So here you can call the display function also in order to print the element in the queue. Next is the deletion operation. For deletion operation, we have to check whether the queue is empty or not. So in order to check whether the queue is empty or not, we are having one condition called friend equal to rear. So if this condition is true, that is the front and rear position are in the same position, we are telling that queue is empty and deletion is not possible. Otherwise, we are deleting the friend element. So only here deleted queue of friend. Then we have to increment the friend because friend is pointing to one position. We are deleting that element. Then we have to increment the friend position. So friend is incremented. And then if friend equal to rear, this condition also we have to check, because if it is an empty stack after deleting, then we have to make the pointer that is the front and the rear position to -1. It is meaning that it is an empty queue. Meaning is empty queue. -1 means. Then the display function, here what we are checking is rear equal to -1, that is whether queue is empty or not we are checking. So So if it is -1, Q is empty, otherwise we are printing 1 by 1. So the condition is for I equal to friend, then I less than or equal to rear, I plus plus. Up to this I less than or equal to rear, we are printing all the elements in the queue. So in this presentation, we discuss about the operations that are performed in a queue, then how to write an algorithm, and here we discuss about the algorithm for the array implementation of queue, then how we have to declare all the variables and functions, all those things we looked up. Then how to write a program to perform the insertion operation, that is EnQueue operation, then DeQueue operation and display operation. In the next presentation, we will be discussing about the linked list implementation of queue. Thank you.